Hello, fellow chemists. And in this video, we're going to take a look at some advanced dosage problems. And this is labeled an advanced video because it does assume that you understand the basic concepts of dosage, how to convert back and forth between mass of patient and mass of drug, and also that you have some basic understanding of how to use dosages and densities to solve for liquid drugs. So if you need a review of those concepts, I'll put a video marker in the upper right hand corner so that you can go and review them. And let's kind of get started with this video. So as a professor, when I write exams and have dosage questions on them, I always put a couple of advanced dosage problems on there, some of the more challenging ones. And those are really to separate out the A students from the B students. And really, there's three things that usually are done, that can be done to make a dosage problem more difficult. And I have them listed out here. And the really, really hard ones could have all three of these things integrated into one problem. But I'll kind of break it down into individual parts here. So the first thing is uh, the drug could be given in tablet form with a fixed mass for each tablet. And then you're looking at a new type of unit there. It's milligrams per tablet. So that just adds a little something extra to a dosage problem. And an example of this is down here for the first problem. Let's take a look at this. It says, if a drug is available in 500 milligram tablets, how many tablets of the drug would a 100 kilogram person take if the dosage of the drug was 20 milligrams per kilogram? Okay, so if we take a look at the pieces of information that we're given that we have 500 milligrams tablets, 100 kilogram person, and then we have the dosage of 20 milligrams per kilogram. Okay, and you don't want to make the mistake of just starting to, do the problem without writing out the information. One of the bigger problems is when people see a 500 milligram tablet, they don't realize how to write that is 5, or any mass tablet, 500 milligrams. They just write it as 500 milligrams, but it's not just 500 milligrams, 500 milligrams per one tablet. Now it has milligrams and tablet units associated with it, which is going to make it much more useful and much more helpful in solving the problem. We also have the person's mass of 100 kilograms, and we have the dosage of 20 milligrams per 1 kilogram. Again, this is drug up here for the dosage. This is a person down there for the kilogram. This is mass of person. And that's drug up there, 500 milligrams of drug. All right, so when you read one of these problems and you think, well, geez, I have no idea where to start. Well, the best way to start is to cancel out units until you get, the only unit left is what you're being asked to solve for. And what is this problem asking us to solve for? It wants to know how many tablets. So really what we want is we want every unit to cancel out except for tablets. And that's exactly what we're going to do here. So if a person's mass is already in kilograms, as with the mass and the dosage, so we can cancel person's mass and person's mass out. So that'll be gone. And then we can set it up so that mass of drug and mass of drug cancels out. And all you're left with is tablets. Okay, so it's once you understand the steps and can see how the units cancel out, it's not too bad. So the first thing we'll start off is we'll take person's mass in kilograms, and we'll use the dosage to convert that to milligrams of drug, and we're using dosage for that. And then in the next step, we'll convert from milligrams of drugs to tablets. And that'll be it. That's the end of the problem. It's just figuring out how to set it up and solve it is the tricky part. But once you figure out the steps, it's not that bad. So we're going to first convert the person's mass from kilograms into milligrams of drug. So we have a 100 kilogram person, and we'll use the dosage here. So we have 1 kilogram We'll put milligrams up there, so it's 20 milligrams of drug per kilogram of person. And kilograms of person cancels out. So we are left with 2,000 milligrams of drug. Okay, now we are in drug form here, so that's mass of drug. And now we're going to use so that's the first step done. We use dosage to get the milligrams of drug. Now we're going to use this term up here to cancel out milligrams and get to tablets. So we'll use that term as a conversion factor. Put milligrams on the bottom because we want it to cancel out, and tablets on the top because that's what we want to end up with. And it's 500 milligrams for every one tablet. And we'll see milligrams and milligrams will cancel out. We'll take 2,000 times 1 and divide it by 500, and we'll end up with 4 tablets. And that is what the problem is asking. It is asking how many tablets would this person have to take. He would take 4 tablets. So that's the first thing that can be done to kind of make a problem a little bit more tricky, is add tablets into it. If we take a look at the second type of thing that can be done to make a dosage problem on an exam a little bit more difficult, is we can add in excess information that is not needed in the problem. I do this a lot as a professor. Students get into the idea, so adding in excess information, students get into the idea that if I put a number in a problem, it must be used. And that's not the way things work in real life. In the real world, if you're working in a hospital or working in a laboratory, there's excess information around you all the time. And you need to know which information is important, what you need to use, and what you don't need to use. So let's take a look at this second problem here as an example of a problem that puts in excess information that you just do not need to use in the problem. So this one says, if a person needs to receive 450 milligrams of a drug, and the drug is available in 150 milligram tablets, how many tablets would a 150-pound person receive? Okay, so it wants to know, the final answer is going to be tablets. So we're looking for tablets. So what information are we being given? He needs to receive 450 milligrams total. That's the total amount of drug that the person needs to receive. We're also told that the drug is given in 150 milligrams per tablet. Okay, so this is drug, and this is drug here. And then we're also told that the person weighs 150 pounds. Well, if we take a look at this problem here, you may or may not realize it when you first see the problem, but it doesn't matter how much the person weighs. It does not matter at all. I could have told you weighed 700 pounds or 1,000 pounds. You don't use that number in the problem. And the reason why you're not going to use that number is because the problem says the total amount of drug that you're going to receive is 450 milligrams. So it doesn't matter if he's 300 pounds, 600 pounds, or 900 pounds. I'm telling you, he's going to receive 450 milligrams of drug. So all you really need to do to solve this problem is have milligrams cancel out with milligrams, and it will tell you how many tablets to give the patient. I have given this problem on exams before, and you would be amazed at how many students, they see this 150 and they think, well, I have to use it somewhere. And they plug it in somewhere, and they get the wrong answer. So once you realize what you're supposed to do, it's a very simple problem to solve in steps. But just putting that extra piece of information in there really does mess a lot of students up. So we want to give the person 450 milligrams of drug. We're being asked to find tablets. And the drug is given, so we'll want milligrams of drug to cancel out. We want to end up with tablets. And each one tablet is 150 milligrams. So when we set that up, the milligrams and milligrams cancel out. 450 times 1 divided by 150 is 3 tablets. It's only a one-step problem. You give this person is supposed to receive 450 milligrams of drug. It's available in 150 milligram tablets, and you give them 3 tablets. Most people would have no problem solving that question if I didn't put this excess information in here of the person weighs 150 pounds. I put that in there, and it just messes a lot of students up. So don't be fooled when you read these problems. Make sure that you look at what information is required and what information is not required when you need to solve them. And then the last thing that professors typically do if they want to make a dosage question more difficult on an exam is they will give you a liquid drug so that you need to use a density to solve the overall problem. Let's pull this up here and we'll take a look at the last question. So, dosages for liquid drugs will require the use of a density. So if we take a look at this bottom drug down here, this bottom question down here, how many milliliters of a liquid drug should a 200-pound person take if the dosage of the drug is 125 milligrams per kilogram and the density of the drug is 0.2 grams per milliliter? So what are we being asked to find here? Milliliters of the drug. Okay, so we'll put that over here on this side. Milliliters of drug. And then we can fill out what the other pieces of information are that we're given. So we're given that the person is 200 pounds. And we're given that the dose is 125 milligrams per kilogram. This is mass of drug up here. This is mass of person down here. And this is mass of a person here. And then we're given the density of the drug as being 0.2 grams per 1 milliliter. And this is drug, mass of drug, and this is volume of drug. Okay, so we're being asked to find volume of drug over here in milliliters. So really what we want to do is have everything else cancel out except for this milliliters down here. Well, if we convert the person's mass from pounds into kilograms, then we can cancel out person's mass with person's mass. And then we'll have the mass of drug in milligrams. We have to convert that into grams. And then we can cancel out mass of drug in grams with mass of drug in grams, and we'll be left with our final answer. So how would we go about solving this? You're going to start with pounds of person. We're going to convert that into kilograms of person. And then we'll use the dosage to go to milligrams of drug. And then we'll go to grams of drug. And then we'll use the density. So this is the dosage here. And then we'll use the density to get to milliliters of drug. So this is going to be a 1, 2, 3, 4-step video or 4-step problem. So let's start off with the pounds of person here and converting his mass from pounds into kilograms. So we have 200 pounds. Put pounds on the bottom to cancel out, kilograms on the top. 2.2 pounds per 1 kilogram. That's our conversion factor for English to metric mass. And we find that a 200-pound person, if you multiply by 1 and divide by 2.2, is 90.9 kilograms. Okay, so that was our first step. We got the person's mass in kilograms. Now we need to use the dosage to get to mass of drug. Put kilograms on the bottom so it cancels out, milligrams on the top, so we have milligrams of drug. And we see that our dosage is 125 milligrams. for every 1 kilogram of person. Kilograms of person cancels out with kilograms of person. If we take 90.9 times 125 divided by 1, gives us 11,363 milligrams. And that is of drug. Now, that was the second step. Now we want to go from milligrams of drug to grams of drug because the density of our drug is given in grams. So I have 11,363 milligrams. Put milligrams on the bottom, grams on the top. Grams is the larger unit, so it gets the 1, and then it's 1,000 to 1 ratio, so there's 1,000 milligrams for every 1 gram. Milligrams and milligrams will cancel out. 11,363 times 1 divided by 1,000 gives us 11.363 grams. So that's now our drug in gram form. That's the step here. And then the last step is to use the density to convert mass of drug into volume of drug. Put grams on the bottom and milliliters on the top. And it's 0.2 grams for every 1 milliliter. So now we have grams and grams cancel out. And if we take 11.363 times 1 divided by 0.2, gives us 56.82 milliliters. And that is the final volume for our drug. So you can see if you're working with a liquid drug and you're doing a dosage problem, it often brings density in so that you can convert the mass of the drug into a volume of the drug. All right, that's it for this video. I hope you learned something. If you did, please subscribe and hit the like button, and I'll see you in the next video.